Good morning, ladies and gentlemen. Thank you for the opportunity to talk to you here today about AI and satellites and how we use that to measure carbon. And thanks for the introduction, Marty. I've been doing satellite analysis since the 1990s, but really in the last 5-6 years, we've been able to do a lot more with satellite technology. We've had better satellites, higher resolution, more frequent revisit times, and particularly by applying AI in a form of machine and deep learning, we've been able to pull a lot more information out of satellite data. So if you think of satellite data today, it's not what it was 10 years ago, for sure. So a little bit about me. My background is in geology and chemistry and soil science, mathematics, applied mathematics, statistics, and business. So what we do is we take satellite data together with other data like soil sample data, vegetation data, and different spectral data. It could be acquired from UAVs or with helicopters, fixed wing, and then satellite data. We combine it all. We apply machine and deep learning to it, and through that we can pull out a lot of information. So if you look at that image, the colorful one on the top is where we did a project on forests up north, for example, and using satellite and sample data, we've been able to identify trees with a very high level of accuracy. So the yellow ones there are trembling aspen, as an example. Of course, AI has been in the news a lot lately with generative AI in the form of ChatGPT and others. So people are becoming more and more aware of it. But it's been around a long time and really started in the 1950s. And after that, we had machine learning come into the picture in the sort of 80s. And really in the 2010s onward, we started to go into deep learning, which are neural networks. So this basically teaching computers to think a bit like the human brain, so where you have nets that work like our nervous system works in the brain. And so how we use AI, if you look at the bubble on the left, you see the overarching umbrella of AI, and within that you've got machine learning, and within that deep learning. And then we have data analytics that cover all of those different spheres. And we use it in computer vision, where we take data, and it could be data in the visual spectrum, so RGB, so red, green, and blue data. It could be multispectral data, where we have tens of bands. It could be hyperspectral data, where we have hundreds of bands. And also satellite radar. We then can collect that data with UAVs, on the ground, and of course with satellite. And from there we apply a lot of machine learning and deep learning to it, and then build some applications. We build all of these things from the ground up using algorithms, which allows us a lot of flexibility in terms of what we can do with it. Also structured data, so there you talk about data that's in spreadsheets or databases. We can handle highly complex data and very large volumes of data, and pull out the learnings from that by applying machine and deep learning to it. So this slide shows you a little bit about the process that we go through. So if you start at the top there, we take soil samples, for example. There could also be probe data. We collect a large number of parameters from the soil samples. We take vegetation samples, and again, collect a lot of parameters from there. Then we typically do UAV data that gives us high resolution spectral data. And from there, we use that as the ground truth into satellite data. So Sentinel-2 is a multispectral free data set at a 10-meter resolution that we like to use because it doesn't cost us a lot at all. It's really only the processing of the data. We also use commercial data at higher resolution where that is necessary. And then Sentinel-1 is a radar satellite that can see through clouds and gives us a different set of information. And from there, we then generate pictures. At the bottom there is the The UAV data set is at 8 centimeter resolution, so really high resolution data set. And from there, we work that into the satellite data that are lower resolution, but allows us to scale over much larger areas. And eventually, at the top picture there, we can then classify it. And throughout that whole process, there's a lot of machine and deep learning involved, and hundreds of different data sets that are typically involved in that process. So I'll show you a couple of case studies just as examples. So this is a project we're busy working on at the moment up north. At the bottom there is, in red, is the agricultural field, and to the north, the different colors is a forest. So it's a good case study location. And you can see from the scale the canopy height. So the height of the vegetation in the agricultural field is about 50 centimeters. But as you move into the green areas there, you go up to 16, even 20-meter height. So we can build this high-resolution, 8-centimeter resolution canopy height model that we can utilize in the next phase of processing, where we use this then and apply satellite data to it. So with Sentinel-1, it can see through clouds, so you're not restricted by the weather, operates day and night, and it gives you that radar data set. And then Sentinel-2 gives us a multispectral data set in the color spectrum. So it uses multispectral, and particularly the shortwave infrared type data is very, very useful when we apply that. So here's an example of an agricultural field by combining soil sample data with satellite data. We've been able to quantify the soil organic carbon in this field. So again, if you look at the scale on the left, you can see it sort of varies from 2 to 4% in that field. In the red area, which has got a little bit higher elevation as well, there's less carbon. And then in the blue area, there's a lot more carbon, sort of lower elevation in the drainage channels. So this provides that scalability where we can do this every spring and fall and get that time series of data, and we can also get the spatial picture. At the same time, as if you look on the scale on the left, we gather information on all the other nutrients and micronutrients as well as part of that process. So we do a holistic analysis. And this is just focused on the agricultural soils. You'll see we've got cutouts where there's water bodies and the homestead on the top right of the image over there. Here's another case study where we've been able to measure biomass accurately using satellite radar. So in this case, the red paddocks that you see there, the farmer planted a cover crop, and it had a cattle herd of about 300 cattle that he rotationally grazed throughout this whole season. So we measured it from the end of May to the end of September. And so the bluer the picture is, the more biomass there is in that picture, and the more brown it is, the less biomass. And so if you look at the chart on the left, the sort of green line is what we've been able to measure using satellite radar. And you can see the biomass increases till basically the end of July, and then it starts to decrease to the end of the growing season after that. And that corresponded closely with what the farmer has been able to estimate in this case study, using animal unit rates to calculate the biomass consumed by his cattle. There's an 80% correlation between the two. So we can utilize this in cover crop areas and also in grasslands. So in the way AI is progressing in society, and particularly in the carbon space, there are really great opportunities to leverage it to help us measure things more accurately and also gather this over time. And since we built this from the ground up, like I mentioned earlier, it allows us lots of flexibility in being able how we incorporate new technology. AI is changing all the time, which from my perspective, loving technology is a great thing. Yeah, and that's really what I wanted to show you guys here in a visual form, what we can currently do in terms of carbon measurements.
Thanks, Peter. We will reserve questions if you're going to be here.